Snowman was saying he doesn't really know much about Zen, and I figured, I think my message to him was probably the people here would be a good place to start learning.
No, sorry, got no idea about that. No idea what you're on about.
Yeah.
Right, no, so for those of you who haven't met me before, I'm Andrew. I work for Citrix. I do theoretically 50% Zen server stuff, 50% upstream Zen, and it feels more like 200% security at the moment. But the I recently I'm doing a huge amount of speculative CPU security and stuff like that, but I'm also an x86 maintainer in Zen and kind of de facto hypervisor lead for Citrix. But originally Zen server, now called Citrix hypervisor, because rebranding everything is a great way to sell more. Yeah, that's me.
Yeah, and then I guess you guys know Michael and I pretty well at this point in time. Daniel from Apertis Solutions, OpenXT guru, Merrick from Cubes, and then I guess Snowman and Grand from the libvfio community. So, Andrew, would you mind at all just kind of giving us a summary of the things that we have very little understanding of in terms of the equivalents or the analogs in Zenland versus the sort of thing that we're used to dealing with in KVM?
Yes, sure. So I have no specific notes on this, but I can certainly talk a bit about it. So Zen's a type 1 hypervisor. It's not like KVM at all. And in a Zen system, the thing called DOM0 is just a VM. This is the bit that trips everyone up. They think it's a bit like KVM host mode or Rails, something like that. Under Zen, the hypervisor is the thing running on silicon. Everything under it is a VM. DOM0 is a VM. It has permissions to manage the system, create new VMs and stuff. But everything is VM. The Zen hypervisor itself is tiny. It's about 2 megabytes text and 6 megabytes in total running in that. It easily fits into L2 cache these days on hypervisor, and that's both the Intel and AMD support. So of course you've got bits that don't fall out there. Zen deliberately manages RAM and CPU scheduling, and nowadays the IOMMUs, and deliberately leaves everything else about the system to other VMs, so DOM0 in this case. DOM0 by default gets every single piece of hardware. It's responsible for disks and networking, amongst other things, and also responsible for creating new VMs, managing, assigning, doing control level operations of assigning hardware to other VMs and stuff like that. So Zen is the mechanism Zen is the entity fully in charge of the system, but most of it is under instruction from DOM0. Now, various attempts are being made to basically DOM0 is your typical I'm a big server kind of thing. DOM0 has all the permissions and all the power and does all the work for it, and that's great if you're a server, and less great if you're, for example, Cubes in a laptop, or other cases where you're looking to try and split up permissions or delegate responsibilities to other areas. So work is being done to more easily split this up. There's kind of a bit of effort done by actually contributed by the NSA to separate the concept of a hardware domain and a control domain. code isn't in the greatest of shape, so Dan is in the middle of rewriting it to do something rather better.
That was actually one of the questions that I had, which was in terms of like the level of maturity in the disaggregated sort of DOM0 model. Some of the questions I was curious about in specific is sort of analogs to IOMMU group bindings, or what precisely we should be looking at. But the other thing was more about like the maturity of this disaggregated DOM0 thing. At the moment, a lot of the logic for libvfio is all kind of bunched up. And if we had to separate the parts out into sort of logical bits that could then communicate over inter-process communication, I guess my question would be like, what would we need to be doing that immediately, or how long would that take to get into Zen or something?
So, different of my hats have different opinions here. Mainly, go for the easy case first. Do the most simple thing for V1, which would be assume a fully powerful DOM0.
Right.
That will, for example, ensure that we get the IOMMU handling right, everything we need in DOM0 sorted out. Disaggregating it thereafter is a V2 exercise, not a V1 exercise.
Right.
It's entirely fine to split the problem like that, just to try and get some achievable milestones in the middle.
Right.
Obviously, I can delegate to some of my friends from the community here for more experience on disaggregating a Zen-based system, but the reality is, once you have got it working in a monolithic DOM0 sense, disaggregating it is not too hard, particularly if you've kind of designed it with that in mind to begin with, but make sure you've got sensible interfaces between components. So for example, sockets can actually be quite easily split across domains-ish. It's far easier splitting a socket across a domain than, for example, a library boundary for a statically linked process.
Yeah.
So a few design considerations like that up front make it a lot easier. But my recommendation still would be to first focus on a monolithic DOM0 sense, because that's going to be enough of a challenge anyway.
Yeah. I have actually a question. Is there a concept of inter-VM memory or like IVSH
IVSH mem.
Yes.
Zen itself provides two. So Zen predates any hardware support for virtualization. Zen started off back in 1997, something like that, and actually was one of the very few bits of software to use 3 of x86's 4 rings of protection to try and build virtual machines with. This is what led to paravirtual guests, where you have a modified Linux that knows it's running under Zen and other variants. So there's FreeBSD, NetBSD, Solaris. There's even a version of Windows XP that ran like this. I definitely don't have the source code to that somewhere. The computer lab has some very interesting archives from back then. Anyway, the point is that under that model, you do need the ability to do sharing between domains. So part of the interface that Zen exposes to virtual machines, one of them is called the grant table interface, which is a mechanism for setting up shared memory. And one of them is the event channel interface, which is a mechanism for interrupts. So those are your 2 base primitives for sharing between domains. There's a third one in progress, so it's part of the disaggregation stuff that's come from the OpenXT world. Upstream, it's called Argo, and it is a hypervisor-mediated, non-shared memory mechanism. So basically, you copy you have the hypervisor copy memory around on your behalf between registered rings. It exists specifically because the US government have a lot of use cases where they explicitly do not want shared memory.
Uh, I also have a question about what is required for this PCI backend. Uh, does it actually require unique device? Domain names. Yeah.
I guess we're curious because we're looking at in the context of NVIDIA, there's like what is the RPM package?
So what I'm understanding from how NVIDIA solved this problem beforehand in Zen is they actually attempted to more or less create additional vGPUs and saying those vGPUs have a different or a completely unique PCI backend device. Now the question is that actually on their own firmware or is it on inside the kernel module that they actually put into Zen?
So, to be perfectly honest, I suspect you know more about how NVIDIA does this than I do. I can certainly talk about what we as a product have as far as the graphics sharing options go, but
Could I frame the question just slightly?
sorry?
Could I have to frame the question, we're looking at Zen GT as our open source equivalent, and then the fact that there's an RPM for NVIDIA, and then one is a fork and one is not a fork, and then if we end up trying to do something with Nouveau, then presumably we'd like to be in the category of non-modified Zen. We're kind of puzzling about why one is a fork and one isn't.
So the reality is that in Zen Server we do have support for all three vendors doing different forms of stuff between full pass-through to virtual sharing. And the answer is there are three entirely different things that don't have anything in common other than the word graphics in their name, basically. It is a total and utter mess.
We would agree.
The Zen GT stuff, we have, there's the upstream Zen GT project, but it's abandonware and it hasn't worked for ages and ages and ages. What we have in our patch queue does work. It is still very old code. It hasn't been touched in a while, but it does at least function, and we do still test it regularly. So absolutely have a look through the source code for Zen Server. Probably easier if you go and nab it from XCPNG, just because they have it published in Git repos. There's politics here, and I won't go into the politics.
I gotcha.
But yeah, XCPNG is basically just a straight root compile of Zen Server plus a few bits and pieces on the side.
Okay. So another thing I was kind of curious about was in the context of GVTG, they have a function called GTV-balloon and GTV-dballoon. And my understanding of how exactly that worked was they were able to allocate memory sort of on the fly to expand the bus address range for a virtual GPU. And the thing is, okay, go ahead.
GVTG is weird in that I think you can split the main bar up 8 ways max, but because of the fact they refused to make a modified driver inside the guest, what they have to do is the guest driver is aware of its subset of the range inside the bar, which has a really weird property that to migrate a VM from host A to host B, you've got to ensure that its eighth of the GT bar is still free. So there are some combinations of migration you can't make depending on which order you booted your VMs in.
Yeah.
There is a huge amount of vendor customization in there, and I would not be surprised if it if there are combinations that are not supported with us that do happen to have restrictions like that elsewhere,
Yeah.
I'm sure this will all see the light of day one way or another eventually. But
Yeah, that makes sense. So the other thing I was curious about, so like obviously with like the libvfio stuff, the vast majority of the interested parties are people who are like running Windows, who hate Windows, and who just like want to not have Windows, but at the same time play video games. And that obviously relies on the thing that I'm understanding from GNIF that he's doing is that it's like the inter-VM shared memory device is one part of having copyless frame buffer share, and the other part of it is skipping a copy in the frame buffer capture. So the thing, I know as much as there's folks who really do not like the concept of shared memory, if we were to eventually do something with libvfio in a Zen context, we would probably have to figure out some analog to displaying on DOM0 in like a looking glass receiver or something like that.
So actually, what we could do, which does tie in with what Andrew said, there's events inside Zen. No, just events. And what we can do is we can actually use those events to actually send CUDA commands or other RAWCOM commands or other commands from the actual device itself. But we would probably have to make our own guest drivers for all of them, and we would have a backend on that is on DOM0, which actually reroutes them to the correct one.
I see there's
So just to clarify, the event channel thing is not is you can think of it just like an interrupt.
Okay, yeah.
It's not,
yeah,
it's
so
not messages.
grant tables and event channels are fully software constructs as far as Zen goes. They are the basic primitives for shared memory and interrupts.
Okay.
Between domains.
What's the limit of how much you can send through at a time?
Well, event channels are 1-bit edge-triggered interrupts. The normal way of doing that is you put a message in a piece of shared memory, send an event channel, and you run the oak handler in the domain you were targeting.
Yeah. So my understanding.
It's important to understand that those are just primitives for setting up communication. You build something else on top of that, however you choose to build on top of that.
Yeah. So we would need to look
there
into
are multiple examples of protocols built on top, including PV drivers, including VChan, which is socket-like thing built on grant tables and event channel, and
So I watched something from FOSDEM. I think it was either last year or the year before. It was on it was either a VNC or some sort of similar implementation for remote graphics for cubes. And the main thing that kind of makes our thing sexy is that like we are using Looking Glass, which is like obviously very performant, so very high frame rate, and not really distinguishable from native graphics drawing because it's just using the same address space and sort of displaying it. If there was some work that we were to do with grant tables, like for example, we tried to get the Looking Glass memory protocol to run on grant tables. I think we have to do something with Spice as well, but hypothetically, would that be like a total off limits for cubes because it used shared memory?
no, that's currently it's not an issue because well, Daniel OpenXT doesn't like shared memory, but we don't have such requirements. So shared memory is fine, just needs to be carefully handled because it's.
And again, I'll go back to my recommendation: get something simple working for V1.
Yeah.
Extra features can come in the future.
Yeah. That could be. Sorry, go ahead.
No, go on.
I was just going to say that I probably would be like the single biggest hurdle right away, besides just getting our heads wrapped around the device mediation model and how it differs from the VFIO MDev. Because the thing that's really convenient about VFIO MDev is there's basically just some files, and we can echo values into the files in somewhere in the file system hierarchy. And it's like, okay, poof, here's a UUID for a mediated device, and then we just pass it via like an IOMMU group. And as long as we can kind of like wrap our heads around the equivalent in Zen, then at that point I think we just start working on a shared memory device.
Yeah, I think we'll start working on this a little bit more after this next big push. So I'm guessing April should be a good starting timeline for.
Sounds excellent.
Yeah.
Well, message you guys with some architecture design questions a bit later in this month.
So, some other things you probably need to know before starting that. At the moment, the IOMMU code in Zen is not great. It is going to need some work here. I have plans, and by plans I mean I've had a lot of time thinking about it. At the moment, there is one single set of IOMMU page tables per domain. So that is Zen can isolate DMA and interrupts as well on a per domain basis. An individual device assigned to a domain gets your standard 90s FireWire style DMA everywhere kind of thing inside it. So this functions from the point of view of isolating different domains apart inside, but is not useful for the fine-grained DMA protection that operating systems are getting used to these days.
Right.
And yes, IOMMU groups are key to that. The work in the hypervisor to change this is to support IOMMU groups.
Yep.
And for that, what we would need to do is change the model. Instead of being an individual set of IO page tables per domain, it has to be basically you need to insert an IOMMU group identifier in the middle there, and then because the way IOMMU groups actually work is that you've got a set of IO page tables per group, and your group delineates what everything inside the same group is shared, and you can also share across multiple groups if you configure that correctly.
So can we actually pre-allocate all the IOMMUs beforehand then?
What do you mean by pre-allocate?
So let's say we had a program that runs in DOM0, and on startup it somehow already knows there's this many allowed IOMMU groups on this particular server. That's related to the hardware. And what we could do is we could split those ones up and have each one of those actually put a portion of the GPU into there. So kind of like the virtual functions from SRIOV, except instead of virtual functions, it's IOMMU. And would we be able to resize the IOMMU on the fly?
So, at the moment, you can't do that because Zen doesn't have adequate interfaces to let you do that. Putting interfaces in like that would be part of making IOMMU groups work. Basically, at the moment, you get DMA mappings as a side effect of constructing the physical address space. Basically, at boot time, you say, do I want devices or not in this domain? If no, then there's nothing in the IOMMU.
Oh.
If yes, the IOMMU page tables are constructed to match the EPT page tables or the MPT page tables on AMD.
Would we be able to allocate empty IOMMU tables and over-allocate how many IOMMU tables?
Yeah, that's what I said.
Yeah.
work to get IOMU groups working in Zen would have to introduce that ability. Yes, at that point, we're building a new piece of functionality. We can make it do whatever is necessary or required or useful to do. But it is building a new piece of functionality that doesn't currently exist. We've wanted it for about 8 years. It's just there's been 8 years of even more important stuff to be doing. So that's also why I have a lot of ideas about how to go about doing this.
How is it related to PVIOMMU thing? Because I've seen something like that.
The less said about PVIOMMU, the better, but I think we do need to get onto it. So, what you're used to in the KVM world is using hardware that and EPT page tables and occasionally MPT page tables if you're on AMD. Zen, because it predates any of this in hardware, also has the concept of PV guests. And PV guests are weird, they're deprivileged. Indeed, DOM0 is a PV guest. The DOM0 kernel runs in Ren 3.
Really?
This is
That's fascinating.
The kernel or the user space for it?
both.
Both.
Okay.
There is a PVH DOM0, but it's
Yeah, let's ignore that. That's got its own problems. This is a consequence of paravirtualizing. This was how Zen made virtual machines work on x86 CPUs before there was any hardware support. So it's a technique called ring deprivileging. We do it by explicitly modifying Linux to know it's running like this and do things differently. VMware, for example, did it by binary rewriting kernels on the fly to do this. So it's a legit virtualization technique, but it has exactly that reaction when to everyone who's not aware of it, and I describe how it works.
It's like Temple OS. It's all in one ring.
Just the opposite, all right?
Well, so I mean, there's a proper interface built in. So Zen knows whether the VM is currently in guest kernel mode or guest user space mode. And there are actually separate page tables built in, so built into the ABI. So the guest kernel page tables are logically different to the guest user space page tables. And actually, from that point of view, paravirtual guests on Zen had no meltdown problems and Intel whatsoever, because we already had 2 sets of page tables, not one.
Right.
Of course, both guest user space and guest kernel could attack the hypervisor because we were limited by the x86 architecture. But yeah, DOM0 is slightly weird, but most of that is hidden in the low-level guts, and most of it you hope we don't need to interact with. In terms of doing IOMU groups, my vague idea was that there would be a new IOMU driver in Linux called the Zen Paravert IOMU driver or something like that, that exposed a normal set of DNA ops to the Linux driver ecosystem, and behind the scenes used a new hypercall to communicate with the hypervisor to set up things like IOMU groups and how would I map this IO virtual address to that physical address or whatever. So that was my plan, and in theory, if you do that, then a BFIO and MDev ought to just start working in DOM0.
That would be awesome.
I certainly think that's the path of least resistance to trying to get something compatible with how the rest of the ecosystem works.
Yeah. I mean, we wouldn't mind doing the hacky thing for now just to get something, but eventually that would be excellent.
Well, actually, we said probably make this into the kernel module either way. So we might as well start trying to do that as well. So.
Well, the thing is, honestly, I think about 85% of the work is probably in the hypervisor, not in the DOM zero kernel. So I don't think there's going to be a happy halfway step to doing it. Obviously, there needs a little bit more design thought going into it before. That's just my gut feel, based on knowing this area of code a little bit.
Also, just a quick question: these Zen API, X API, is that up to date?
So, the thing called Zen, or Zen API, is the tool stack for Zen Server. It's all on GitHub. For complicated reasons, our production branch is master on GitHub, which comes with its own set of challenges of accepting PRs from other groups of people, but again, politics, I won't get into that. Short answer, yes, the code you see on GitHub is up to date and very definitely bleeding edge. It's also bleeding edge that is also shipped in the product.
Okay.
It's all written in OCaml. I'm sorry for that.
Oh no. I love that. I would prefer Haskell, but OCaml's fine.
So we were in a really stupid position where Zen Server used OCaml and Zen Client, who were the next group along in the office. I mean, we literally shared seats in the office. Wrote in Haskell. So some of that still remains in OpenXT. And then there's the thing upstream that's XL and libxl that was tasked to be written as a bottom complet, both of them, by someone who didn't know what he was doing and managed to make something that is impossible to integrate into anything that isn't C. In particular, it will segfault a lot of virtual machine runtimes, so you can't integrate it into OCaml, you can't integrate it into Haskell.
Yeah, that was actually what I was curious about. So when I was watching the presentation from the GVTG developers, I noticed they were talking about libxl and also Merrick. I think you also linked something relating to libxl on GitHub. And I'm curious how exactly that connects in with the device mediation model and where it sits in the stack.
So, I need to find someone in Citrix did a pretty good picture of which components talk to which others. I'll see if I can find that and shuffle it to you.
Yep.
Basically, there's upstream zen.git, which is the upstream project, and in that you've got the hypervisor, and you've also got various random MISC stuff for DOM zero. And the tool stack in there is the XL tool stack that uses libxl, that under the hood uses some lower level libraries, so libxc, libzen control, libzen yes, libzen evention, libzen guntdev, libzen guntab, libzen device model, libzen call, libzen hypercall.
Lots of libs.
People went a little bit overboard on subdividing their libraries. Yes.
I can see that, yes.
But basically, all of those libraries live in zen.git, which is upstream Zen. There's libxl, which is a library. There is xl, which is a reference implementation on using libxl as a library to do stuff. There is a libxl plugin to libvirt, so libvirt can use libxl on a Zen system to do stuff.
Which
it
one look at that?
occasionally compiles.
Yeah.
SUSE use it, but yeah, it's kind of there. It kind of works. It could probably do with a bit of love and attention, but it gets fixed up when it really breaks.
Yeah, we'll have to
So-
look at that, in particular, the libvirt implementation.
I recommend not getting involved there in V1. By that point, there are at least three levels of libraries wrapping each other, going down through the stack.
Yeah.
Yeah, so generally the tool stack part involved, I guess, will be a rather small amount of work, but also it's very easy to break things when you do anything around libxl, because yeah.
Okay, fair enough.
libxl would be rather better written in M4 than C. That's how bad it is.
Is there a particular component
Actually,
besides
some of it
libxl?
is kind of written in Perl to auto-generate.
This is written in Perl?
No, there are bits of Perl written in the build system to auto-generate bits of C.
That reminds me of mdevctl, which is a component that we kind of like incorporated the functionality of in
It's
libvirt.
Rust to generate bash.
Yeah.
And some of the code we currently have actually has Haskell to generate C to generate machine code. So
Yeah. A little weird.
that's not going into production anytime.
I want to see it.
Yeah, so I guess the other thing to say is that Zen API, as you've seen it, it links in. It generally uses libzen control, and libzen guest, which are the two lowest level bits of the tool stack. And I'm the numpty that always has to fix the ABI breakages because they don't have stable ABIs or APIs. So the Zappy tool stack is fairly separate to everything else we've just described. There's a kind of wish inside the Zen community to try and pull things back together a little bit, but again, that's hugely future work. Don't worry about it too much. Your best bet is to start with plain upstream Zen and get something working with the XL tool stack.
Okay.
I think.
Is there any automated build systems you guys would recommend for building and testing Zen? Or would we have to make our own?
We have our own problems there. We're pretty good on build testing. Actually, runtime testing is a totally different matter. And honestly, I'd like to jump what we've got and redo it from scratch, but that's not the easiest thing to do. We can certainly help you out there. Zen server, we just use plain Koji builds. OpenXT uses Open Embedded. Cubes, I think, are just plain builds again as well. There's a lot of stuff out there that's reasonably easy. You've just got a large number of moving parts.
Okay, that makes sense. So, I mean, I think at this point in time, on the recommendation of Rich, who very, very strongly recommended we stop working on the flashy Lime feature, we've stopped that, and I think we're focused entirely on packaging and just getting things together where we can hopefully reach like a 1.0 release where we have like a stable YAML, and then between versions we can migrate people's YAMLs between versions.
Yeah.
So I'm assuming when that's done and when we have the initial Arc GPUD thing,
Yes.
then perhaps what we could try is to do something like an install script initially, maybe not packaged, but like an install script that gets you to a workable state with some kind of Zen. But we would have to probably read about the libxl API and get a sense of exactly how to create these mediated devices.
I'm afraid I won't be here because I've got another meeting at the top of the hour.
Thank you so much for coming. Appreciate it. Bye-bye.
So yeah, what else? Yeah, as I said, I've only got 15 minutes. I guess thing we ought to talk about is how some of the graphics sharing works right now.
Yep.
I use this mainly as an example of what not to do.
Okay.
So you're fairly familiar with GBT-G,
A little bit.
which is basically a part of hacks and QEMU.
Yes.
One thing there that depends on something in the Zen server patch queue, and that is not upstream as far as I'm aware, is basically, so remember I said that the I/O page tables are per domain,
Yeah.
and an individual device is assigned to an individual domain.
Yep.
As a consequence, that means that wherever the device lives, it is bound by the page tables for the domain. So for GBT-G, the device lives in DOM0. It's the i915 driver in DOM0 that's driving all of it. We have some utter gross hacks whereby when QEMU maps memory of the domain, IOM and U mappings get set up for it. So what you end up with is a single set of IOM and U page tables that are a scattergun of identity mappings across the system. So one thing I didn't get onto about PV guests. PV guests, that we call them virtual machines, but they actually work. They function quite similarly to regular user space under a native OS. You start from a single ELF file. It gets random memory assigned to it that it doesn't really control. It gets to see what that memory is. It gets to manage it, but it has no choice on where its memory lives. And it is a smattering of 4K pages, because it turns out doing reference counting on super pages is hard and full of security issues, so I turned it all off. So PV guests are exclusively 4K pages, and they are generally non-contiguous in both physical address space and the guest's idea of its own physical address space, which are different concepts. But DOM0 being all-powerful has what we call foreign map privileges, so it can say, I want to map that thing in that domain, please.
Oh, okay.
So we have to do that, for example, to build a domain initially. So you create a domain, then you give it some RAM, and then you've got to copy the bootloader in, or the initial firmware, or something like that. So we've got to make a mapping of the domain memory to put the initial executable content in. Also, you need that for live migration. We have to map the entire domain, then copy it, deal with logos and bitmaps and so on. So DOM0 using some privileged permissions can map arbitrary parts of domains. And that's also how QEMU, for example, does emulated DMA, in the case that you're doing QEMU emulating the motherboard. And yeah, that's how that side of things works. It's different to, for example, the PowerVirtual NetFront and NetBack drivers. They were designed in mind where your back ends and your front ends were in separate domains and mutually distrustful of each other. So one key security property that the grunt table model has, that nothing else in the world of Vert has, is that a backend may only map memory of the front end that it was explicitly given permission to.
And that's given permission by DOM0 via this foreign map privilege?
No, so DOM0 has special permissions for foreign map, but that's all tool stack administrative stuff.
Okay.
It is separate to the logical data path for network and disk. And like I said, it's very common for DOM0 to be monolithic and have both the data path responsibilities and the control path responsibilities. But that's not the only configuration that exists, and the radically disaggregated DOM0s do split this. So, for example, you'll have DOM0 that's in charge, but you'll have a network device drive domain and another network device drive domain and a block device drive domain and whatever. So in that case, the back end is in the driver domain, the front end is in the guest.
Right. Okay, that makes sense.
And the back end or rather, the grant table interface provided by the hypervisor will only permit me to map a grant reference that I was given by the other domain. So Zen enforces that the backend can only map explicitly permitted pages in the first place.
Okay, that makes sense.
And it means that right from its inception, there was no such thing as your emulated disk can arbitrarily DMA over the front, over the VM. That never existed in the Zen model. And of course, Vert.io comes along, gets really, really popular, and reintroduces this problem across the entire world. But BS, so that's around. Realistically, most things when it comes to QE or emulation have just given up and gone for the let's DMA everything everywhere approach, again, because it's easy. It turns out people far prefer things that are fast than things that are secure. Ideally, we do both.
Yeah.
So, for GBTG, the graphics card is in DOM0, controlled by DOM0, and we make foreign mappings of generally guest kernel memory for buffers, as and when the device needs to DMA into the guest. So that's a whole pile of crap on the side. Basically what happens is the emulator there's the i915 driver and there's the GBTG driver that's kind of subordinate driver to it that never ever got upstream into Linux. But it's in our kernel patch queue. It's fucking massive. It basically sits and interprets the command queues for the graphics cards and sets up mappings and shadows the GTTs inside, shadows the graphics page tables inside the guest. There's even a mechanism for getting the bright traps from the guest, so it can shadow page tables living inside guest RAM. It's there, it works, it's horrible, it's hacky, it's gross. The end result is that DOM0's single set of IOMMU page tables lets the GPU lets the GPU have permissions to get to every bit of the guest that it is interested in DMAing to.
Is it similar without necessarily, or maybe divulging something you can't say, is the approach similar in having all this memory controlled by DOM0, I guess this forward mapping sense with NVIDIA as with the Intel GBTG stuff?
It's totally different with NVIDIA.
Okay.
With NVIDIA, we had to do something a little bit different. So, as a slight quick tangent, we had this thing called PVIOMMU, which was specific. So, if you remember, I said PV DOM0 has non-contiguous pages, and that's actually a problem for network cards in particular that can't do 4K scatter gather that do want to use jumbo frames. And it turns out there are a very large number of those in the world. So what we actually do is we set, this is local to the Zen server patch queues. We tried upstreaming it and got nowhere, and then the person in charge of it left, and I've got this big rotten pile of IOMU code that I would like to delete. We set up IO virtual addresses for DOM0 to counteract how they're scattered normally in the host. So from DOM0's point of view, IO virtual address is equal to what Linux thinks is a PFM that isn't actually a PFM in real memory. Which means that your translation between, which means your DMA map and unmap are identity operations. But what it means is that the network cards that can't do network cards that can't do 4K scatter and gather still actually go at a sensible speed when you've got jumbo frames in use.
I've got,
Now,
I think, sorry, go ahead.
The second thing you need to know about that is that to make NVIDIA work on that, we also had to, they didn't do any of this, and they went and actually reverted a patch that had been deleted out of Zen 4 years previously that basically said, hey, this guest address, where is it in the host? We reverted that because it was a massive layering violation, and now we've had to put it back in. What we do with DOM0's IOM and UMAX is we've got the lower half from 0 to up to n that basically undoes the fact it's not contiguous in real memory. And then we've got an identity map of the whole of host RAM. Yeah, it's terrible. It really is terrible. But it means that your DMA map for NVIDIA is plus 256 gig, and then assume identity mapped from there.
Yes. Wow.
It is terrible. I really wish that would go away, but that's how it currently works. Also, this is where we discovered that a lot of NVIDIA graphics cards only have 39 address bits wired up. It turns out ship breaks quite hard when you try and give it a DMA address above 1 terabyte.
Interesting.
Because what happens is you actually it claims 64-bit DMA capability, has absolutely no errors with it, but actually the address cycles it generates are 64-bit mod 1 terabyte. And when you're doing that into an identity map of the host, suddenly your DMA lands in random places it shouldn't.
I think that covers pretty much the majority of the questions that I had written out ahead of time. Is there anything else?
Not on my end.
Snowman, Ben, did you guys have any questions for, we kind of have like, you know, some of the smarter folks in the world available?
Not really.
Snowman, do you have any questions you've written out that we've missed? Not really. Okay. All right, well, I think we have kind of a rough...
As I said, feel free to grab me on wire. If you want another call, I'm sure I can talk. We'll have a lot to talk about come Patch Tuesday on Tuesday. That's why I'm so busy right now. But
okay, sounds good.
I'm afraid I have another meeting I need to get to now.
No worries
Have
at
a
all.
nice day.
Thank you for coming by.
You too. Meet you.
All right, sounds good. Okay, I think just coming out of this, all we really need to do is hop on, do some work on getting the packaging stuff finished, and then maybe we could try to look into libxl and understand the API and do something with it.
Hey Arthur.
Yep.
Question: Who's talking about Camel and Haskell?
Sorry, 1 second.
Oh, who's talking about old Camel and Haskell?
Oh, this is Michael. You were talking about
Yes.
it. Yeah.
I'm also in the Wire group.
Michael is CTO. You know him. You talked to him quite a bit, I think.
Yes. Yeah. No, I just wanted to make sure. So it's a very dangerous thing to say to this crowd because we've been looking for such a person for about 10 years. So you might get kidnapped flying anywhere or something.
Yeah.
So what do you think about Rust?
So I am actually using Rust currently for the ArcD GPUD. Unfortunately, there's quite a few limitations that I actually dislike quite a bit about it. And you can't do certain things as easily. I more or less hate it, so. But I'm using it right now to actually get a sense of it in case we will have to deal with it. But overall, it's not the best programming language by far.
I have a small little pet project to try to rewrite our existing code in Rust, but we'll see whether or not that overtakes the existing one.
Wow. Okay, that's impressive. So you're the only person I think I've heard ever who said anything bad about Rust. And sorry, anything bad about Rust, anything good about Haskell, and anything good about Cat. So, like the Venn diagram there is like one person.
Yeah.
Interesting combination.
Yeah, Michael's a unique guy.
Okay, no, it's very good.
Yeah.
avoiding the file shrinkage, right? Because still do block storage, I think, probably will do.
I think we'll probably revisit it at some point, but I think you're correct in that right now the biggest challenge is that we don't have proper packaging, and we should address that first. So that's what we'll do.
Yeah, I mean, that's something that should be focused on to make sure it's a lot easier to install than it currently is. And also to make sure there's like a migration from one version to the next to avoid issues like we're having at the moment where the only version is bleeding edge
Yeah.
or individual commits, which can be dangerous if someone like pulls it at the wrong time.
Yeah, I think that's all accurate. Okay, is there anything else you guys wanted to
No, not
wrap
on my
on?
end.
So, sorry, so when's your next call? Are you doing it Wednesday?
We're doing them is the first Wednesday of every month.
Yeah, and we'll try to establish a calendar like the example that you gave, I think, on 3M Deb. That, I think, was an excellent example of how to do it.
Yeah, and did you figure out your position on recording or not recording?
What we're trying to record at the moment, but whether or not that was actually a success in how it worked, we'll have to see after the fact,
Yeah.
and we might edit some things in and out, and we may actually choose to do it privately instead, based on some of the folks we might like to have join. So I don't think we've established one way or the other quite yet.
Okay.
I think one thing I want to add is like sort of like about not focusing on the line right now. Like, I think at the moment, like I said, like there's not really any easy way to copy files into VM.
Yep.
Other than messing with Samba and possibly messing up, like if it's on a server, then.
So I believe one of the things we actually did enable is SSH. I could be wrong there.
It is, yeah.
But with SSH you can also SFTP the files and do an SSH file system there. So that could be used temporarily as, how do I say it?
File share.
Yes.
There is one samba.example, or excuse me, samba.example.yaml that's, I believe one of the commands is it actually calls the samba daemon in user bin, and you can specify a custom config file. So if you'd like to do that in a way that hopefully doesn't overlap with
I think one thing with that at the moment is I think that might have broke on Arch, because I don't think Arch has a Samba like service.
Yeah.
Yeah.
Let me just make a quick comment. The purpose of whatever it is you're trying to do, okay, is to provide a very compelling use case, right?
Yep.
And you want to show people something that they have not seen in other contexts,
Yep.
which they can somehow, because basically nobody can make anything anymore in our current reality because we're not really sure where to reality is.
Yep.
So they see a video, it's cool, but very next thing, well, how can I do? So we want to do something where they can see something physically on their hardware.
Yep.
The only layer, like that's the stuff that they're seeing on their hardware is different than the stuff that they're using in production.
Yep.
There's like a few, so you should stop thinking about the user interaction and you just focus on the give them a thing they can run their hardware. The best way to do that, which I think Zen did, Open-IOV did, Cube did, and all of it 1 point early, but it usually stops being maintained after it works because you want to actual production set. But the thing maybe that's easy to consume is a live CD, basically, right? Not a physical CD, but live in it.
Right.
Do from USB. And the reason for that is your packaging probably goes away because you have a control.
Right.
So that would be my recommendation. And then, if you agree to do that, then there's a possibility immediately of, well, hey, can I piggyback on somebody else's live CD?
I hadn't even thought of that, like a live environment for libvfio.
Well, it has to be either way. If we make the ISO, we have to make a live CD.
Well, of course, but like in the context of the existing ISO, it's just an installer. Whereas imagine if we had like the equivalent of Ubuntu, where it's like try Ubuntu versus install Ubuntu.
It was a later goal, I thought.
I didn't think so,
Right,
but that's
Exactly.
great.
So make it an early goal.
Okay.
Because putting packaging stuff for arbitrary distro is an absolute nightmare. And I know for sure.
packaging.
Pardon?
The biggest issue with this so is the files we will have to be working with are like 300 gigabytes. So they would need an external SSDs that they can use.
For the Windows image.
Hold on. Did you say 300 gigabytes?
The virtual disk image, but those can be done. QCOW, hold on. We don't actually have to. Hold on.
I'm not
Those can be
talking.
done without pre-allocating.
I'm not talking about that. What I'm talking about is when you use this live CD.
Yeah.
This live CD has to be able to actually create these scenes.
The QEMU image.
Yes.
Yeah, but I'm saying that you can, in the context of
You don't need the full 300 gigabytes.
without doing pre-allocate, yes.
Yeah, but the thing is, if I recall correctly,
300 megabytes, right? Not gigabytes.
no
Okay,
gigabyte.
Rich, what he's talking about is when we're creating a QEMU image, unless you turn on pre-allocation equals metadata, it creates a 300 gig file, which is something that I think we should be doing.
But the thing is, even if you don't turn that on, when you use QEMU image, I believe there's a check that actually checks if there's enough room.
No, there isn't.
I haven't failed.
I've over-provisioned many times.
I can't remember. There was one where this is a problem to fix it. So you shouldn't have any of that. You should have one pristine image, and you do some kind of film division. So your image should be like 10 megabytes or something.
Yeah, exactly.
But we still will
I can fix that.
Yeah.
It's easy enough.
Okay, fine.
But, and if you can't fix it, we have lots of people.
It's 100%. I've already fixed it. It's just not in the branch that you're thinking of.
I'm not talking about that though.
We'll talk about it.
Yeah, we'll talk later.
But
Yeah, so-
here's the key. If you want to get to the point where people can download a thing, put that USBs, put that into their hardware,
Yep.
have a demo that convinces them that the physics work.
Yep.
Be absolutely blown away, unplug the thing and make sure no damage is done to their machine.
Right.
And then from there, you want those to come back to you and say, hey, I will pay the time or money or whatever for you to make this in production and tell you exactly what they want in production.
Yep.
That's a completely different in terms of market validation, much better solution.
Yeah.
So give them the basic thing and then tell you what they need for it.
Correct, yes, because we are in a complex world where no human at this point has a proper level of reality. Most of the world is not public, and everything that's occurring in public is a proxy war for something else. Okay, so you hurt your brain if you try to solve a command that's invisible. Whereas if you give something that proves that you have some, your work produces a side effect that no one else has done, which you have done, okay, already. So that you've done all the part. So it's about communicating with other people. So the existence proof on USB communicates it. And if it's sufficiently compelling, then they have a reason to justify communicating their private non-public requirements in a proxy form, right? So their requirement is imaging of non-public data streams, and they'll come back to you with some Netflix results. See what I mean?
Yeah.
So everyone needs to they have to be able to prove that you are talking to what you know what they do, and then they'll figure out how to wrap up their private need into some public proxy. And if you have to come back with a common public proxy, then that can be the thing you build into something like because people say, well,
That's fantastic.
suggestion.
I mean, I think that the live USB environment, that we should do that right away.
We say
Yeah, the live USB environment would be good if possible.
And,
Yeah.
and there's lots of places, and then you can choose what you want to derive from it. So
Yeah.
that's fine. There's that, there's a time.
Yeah. I think our next meeting is here, so we have to hop out.
Okay.
have fun.
Alright.
Okay. Thanks for talking. Thanks for coming, everybody.
Alright.
All right. Cheers. Bye-bye.